Our next topic is going to be access control lists. And the access control list allows you to control the security on your device, on your routers. It can act as a firewall for your network. With the Cisco routers, we can configure the simple firewall that provides basic traffic filtering capabilities using our access control list. Just think of the name, access control. So we're controlling the access to our routers. Network administrators use these ACLs to stop traffic or to permit traffic, only specific traffic on their networks. Okay, so it's controlling what comes in, what goes out, exactly what type of information or type of packet comes in or out. And an ACL is just a sequential list of permit or deny statements. That means I'm going to permit you to come in, or I'm going to not deny you to come in or to go out, that apply to addresses or upper layer protocols. With ACLs, they provide a powerful way for you to control traffic into and out of your network, and they can be configured for all routed network protocols, not a specific protocol, but for all protocols. The most important reason to configure your ACL is to provide security for your network. So, with our ACLs, the purpose of those are to determine what packets of information are allowed in or denied from coming in, what's allowed out. So our access control list with our Cisco routers are going to help you with your security. You can deny certain types of information to come to certain routers. Perhaps you don't want people behind one router or one network to have access, let's say, to the internet, or you don't want them to be able to receive telnet communications. So we can configure our ACLs on our routers in order to do this. Some of the ACLs, they do some of the following. They're going to limit your network traffic, and this will increase your network performance. If you're only allowing certain types of packets in, then you're controlling the amount of network traffic you have. It provides traffic flow control. It provides a basic level of security for your network because you're allowing or denying information. It's going to filter your traffic based on the traffic type. And then the screen host to permit or deny access to the network services. And ACLs can permit or deny a user to access file types such as FTP, HTTP. So you have a lot of control over that. Maybe you want to deny them access to updates. You don't want other people to do updates on your system. You want to have control over that. So by default, a router does not have any ACLs configured on it. Your router's wide open and traffic can flow through your routers in any direction, in any type of packet. So we put these ACLs on there to control what is coming and going on our network. Now our ACLs are going to enable you as the administrator to control the traffic on your network, both in and out of the network. And this control can be as simple as permitting or denying traffic based on a network address, or it can be very complex based on the TCP port being requested. And it's easier to understand how an ACL filter traffics by examining the dialogue that occurs during a TCP conversation, such as requesting a web page. And you'll notice the communications that's been diagrammed here on the screen on the right, where it has the TCP conversation. You'll see that you have your TCP where we send let's talk, we get our acknowledgement, I acknowledge that I acknowledged you, and then the transmission of the data and the acknowledgement that I've received it, and then the TCP finish, and then the acknowledgement of the finish. Now with TCP communications, it provides a connection oriented, which means we have to have a connection, and it's a reliable byte stream service. Now keep in mind that TCP has to have acknowledgments from the applications from both ends. It's full duplex protocol, and it means that the TCP connection supports a pair of byte streams and each stream flowing in one direction. With the TCP, it includes the flow control mechanism for each byte stream, and it allows the receiver to limit how much data the sender can transmit. And it also implements a congestion control mechanism. Okay, so you need to keep that in mind. We can also look at the known ports. 0 through 1023 are considered well-known ports. 1024 to 49151 are registered ports, and 49152 to 65535 are private or dynamic ports. And if we break that down a little bit more with our well-known ports, we know that 21 is for FTP, 23 is Telnet, 25 is SMTP, 80 is HTTP, 143 is your IMAP, 194 is your IRC or Internet Relay Chat, and then 443 is your secure HTTP. Now with your registered ports, some of those you have 1863 is MSN Messenger, 2000 is your Cisco Voice over IP, and then you have 8008 or 8080 as alternate HTTP ports. We also have 69 as the TFTP, 520 is RIP, and then with the well-known or the registered ports, we have 1812 is Radius Authentication Protocol, and 5004 is RTP, and 5060 is SIP. You do need to know some of these, especially the well-known ones. You need to know what they are. So we're talking about our packets, how they're going to travel across our networks, which ones we're going to allow, which ones we're going to deny. And basically the packet filtering controls access to your network. It analyzes the incoming and outgoing packets, so it looks at both those that come in and those that go out, and passing or dropping them based on certain criteria, such as your source IP address, your destination IP address, and also it looks at the protocol carrier within that packet. Now your router can act as a packet filter when it forwards and denies packets according to your filtering rules. And when a packet arrives at the packet filtering router, that router is going to extract the information that it needs from the packet header, and then it's going to use this information to make its decisions based on configured filtered rules as to whether we're going to allow it or deny it or discard it. The packet filtering can work as at different layers of the OSI model or at the internet layer of the TCP model. So as you see here with the OSI model, the packet filtering is going between the transport and the network layers. Now a packet filtering router, it uses rules, like I said, to determine whether to permit or deny your traffic, and it can also perform the packet filtering at layer 4, which is your transport layer. The router can filter packets based on the source port and destination port of that TCP or the UDP packet segment. And these rules are defined using your ACLs because it's your access control, and the L's for list. So we're going to control the information. With our ACL, like I said, it is a sequential list of permit and deny statements, and they're commonly called ACL statements, okay, because it's access control entries. They can be created to filter traffic based on certain criteria, such as your source address, your destination address, your ICMP message type. So it's going to look at all this information at layer 3 to determine what comes in and what goes out. The ACL can also extract upper layer information from your layer 4 heading, including your TCP UDP source port and your destination port. Remember, we just spoke about the different ports that are well known, so you've got to keep this information in mind as well. Now with our ACLs, what we're going to do is we're going to define our set of rules that give added control for the packet that enter inbound interfaces, packets that relay through the router, and also for packets that exit outbound interfaces on the routers. Okay? They do not act on packets that originate from the router itself. It's just information that's coming to the router or leaving the router. Your ACLs can be configured for inbound traffic or outbound traffic. Your inbound ACLs are incoming packets. They're processed before they're routed to the outbound interface. And an inbound ACL is efficient because it saves the overhead of routing lookups. If the packet is discarded, if the packet is permitted by the test, it is then processed for routing. So if it doesn't meet the criteria, we're not going to process it, we're going to drop it. Now, your inbound ACLs are best used to filter packets when the network is attached to an inbound interface and its only source of packets needed to be examined. Now, your outbound ACLs are incoming packets are routed to the outbound interface, and then they are processed through the outbound ACLs. Your outbound ACLs are best used when the same filter will be applied to packets coming from multiple inbound interfaces before exiting the same outbound interface. Okay? The last statement of an ACL is always an implicit deny. And this statement is automatically inserted at the end of each ACL, even though it is not physically present. Okay, so you've not typed it in, it is just automatically implied. The implicit deny blocks all traffic, and because of the implicit deny, any ACL that does not have at least one permit statement will block all traffic. Okay, so keep that in mind. Now, with Cisco and IPv4, we have two types of ACLs. We have our standard ACLs and our extended ACLs. Your standard ACL can be used to permit or deny traffic only from source IP addresses. Okay? The destination of the packet and the ports involved are not evaluated. It's only looking at the source. Okay? The extended ACLs filter the IPv4 packets based on several attributes. So it's not just looking at the source IP address. It's going to look at the protocol type, the source IPv4 address, the destination IPv4 address, your source TCP or UDP ports, your destination TCP or UDP ports, and the optional protocol type information for the filter. Okay, so here in this example we see the standard ACL, and it's filtered the IP packets based on the source address only. So it says access list 10 permit the IP address or that network 192.168.30.0, and we've got our wildcard mask there, which is going to let everything in that 24-bit network in. And then our extended ACLs, it filters the packet based on several attributes. Okay, it's got the source IP address in there. It's going to look at the source and destination TCP and UDP ports and the protocol type. So this one says access list 103. We're going to permit TCP. Okay, so that's what it's looking at, TCP, from the 192.168.30.0 network. It's going to permit anything, and it's going to go through port 80. Okay, so and what was port 80? If you remember correctly, port 80 is your HTTP port. Now, with standard and extended ACLs, you can create them using either a number or a name to identify the ACL and its list of statements. Now, you'll notice that if you use a numbered ACL, you can assign a number based on protocol to be filtered. You've got 1 to 99 or 1300 to 1999, and those are for your standard IP ACLs. With your extended IP ACLs, you can use 100 to 199 and then 2000 to 2699. Now, if you use a named ACL, you have names can contain alphanumeric characters. It's suggested that the names be written in capital letters. It just makes it easier to see when you're looking at your configs to make sure you have things in there right. It kind of stands out. Names cannot contain spaces or punctuations, and your entries can be added or deleted within the ACL. With your ACLs, when you're configuring those, your access list, you're going to have your wildcard mask just like we did with OSPF. Now, you could list each of the networks. The example here shows the access list 10 is going to permit the network 192.168.10.0, and then it also lists the next network that's going to allow access to your router. However, if you go through and you use your Wildcard Mask, you can have one entry, and it would say access list 10, permit 192.168.10.0, and then you're going to put your subnet mask or your Wildcard Mask on there, which would be 0.01.255. Okay, so that's what we could look at, and it's much more efficient. You don't have a chance of miscalculating or typing something in wrong as long as you get your Wildcard Mask correct. The example here shows you a long list of networks that we would have to key in each of the networks, or you can do an access list with the originating IP address or network with that Wildcard Mask, and it just makes things a little bit easier, a little bit more efficient in configuring your routers. Besides having your Wildcard Mask, you can also have a Wildcard Bit Mask keyword, and that comes in handy. You may want to use the keywords, or you want to use them to eliminate entering Wildcard Mask when identifying a specific host or an entire network. And the keywords also make it easier to read an ACL by providing visual clues as to the source or destination of the criteria. In this example that it's given us here, the host keyword substitutes for the 0.0.0 mask, so we say host. The mask states that all IPv4 address bits must match, or only one host is matched. The any option substitutes for the IP address and the 255.255.255.255 mask. This mask says to ignore the entire IPv4 address or to accept any addresses. Okay, so here in the first example, instead of entering 192.168.10.10 with quad 0, you can use host 192.168.10.10. And in this figure here too, instead of doing the quad 0, quad 255, you use the keyword any by itself. So it would say access list 1, permit the quad 0 with the quad 255, and then the access list permit any. Or you can have access list 1 permit, you have the IP address with quad 0, and you're going to tell it to permit the host 192.168.10.10. Your ACLs can be very complex on your routers, and you need some guidelines when setting up your ACLs. Some of your basic guidelines are use ACLs in firewall router position between your internal network and your external network, such as the internet. You're going to use your ACLs on a router position between two parts of your network to control traffic entering and exiting a specific part of your internal network, and you're going to configure ACLs on border routers. That's your router that's situated at the edge of your network. And this is going to just provide a very basic security for the outside network or between a less controlled area of your own network and a more controlled area. You're going to configure ACLs for each network protocol configured on the border router interfaces. Now, besides these guidelines, there's what's called the 3 Ps. It's a general rule for applying ACLs on a router, and they can be recalled by remembering these 3 Ps. You're going to configure one ACL per protocol, per direction, per interface. So, one ACL per protocol to control traffic flow on an interface. Your ACL must be defined for each protocol enabled on that interfaced. One ACL per direction, so the ACLs control traffic in one direction at a time on any interface. 2 separate ACLs must be created to control inbound and outbound traffic. 1 ACL per interface, so ACLs control traffic for an interface, for example, your gigabit port. Okay, so keep this in mind. So you can see that your ACLs are going to be able to help you on your security, but can you also see that you really need to plan for your ACLs? Because if you don't, you can have a lot of difficulty. You can have some downtime if you get things misconfigured. So take your time, before you actually configure the ACL to plan out what is truly required. Now, the image here on the right you can use as your ACL best practices. You've got your guidelines and the benefits. So keep this in mind. It wouldn't be bad to write this down or to keep it handy when you are creating your ACLs in the future. So we've talked about our guidelines and the 3 Ps. Next, let's talk about the placement of these ACLs. All your ACLs should be placed where they're the most efficient and where they're going to have the greatest impact on your network. With extended ACLs, you're going to locate those as close as possible to the source of the traffic to be filtered. This way, undesirable traffic is denied close to the source network without crossing the network infrastructure. Now, with your standard ACLs, because they do not specify destination addresses, we're going to place those as close to the destination as possible. Placing a standard ACL at your source of the traffic will effectively prevent the traffic from reaching any other network through the interface from that ACL. Okay, so extended ACLs are usually placed near your source. Your standard ACLs are usually placed near the destination. Okay, so your placement of your ACLs and the type of ACL used may also depend on several things. The extent of the network administrator's control. Okay, so how much control do you have over this? The bandwidth of the networks involved, because filtering unwanted traffic at the source prevents transmission of your traffic before it consumes up your bandwidth. So how much bandwidth do you have? Do you need to control? How much control do you need to have over that? And ease of configuration. If the network administrator wants to deny traffic coming from several networks, one option is to use a single standard ACL on the router closest to the destination. There is a disadvantage, and that is that the traffic from these networks will use bandwidth unnecessarily. Okay, so that traffic didn't need to go to that location to begin with. So an extended ACL in this instant would work a little bit better. Now, if you're planning on taking the CCNA certification, the general rule is that your extended ACLs are placed as close as possible to the source, and standard ACLs are placed as close as possible for the destination. So keep that in mind if you are planning on taking the CCNA once you complete the Cisco Academy. So if we're looking at a standard ACL, it can only filter traffic based on a source address, and the basic rule for placement, remember, is to place the ACL as close as possible to the destination network. This is going to allow the traffic to reach all other networks except the network where the packet will be filtered. Remember, if you put it too far away, then you're going to block traffic throughout your whole network. Okay? So keep that in mind. This is a good example here showing you where to place your standard and where not to. So take time when you're going through these and reading this to study this particular information here. Now, similar to the standard ACL, your extended ACL can filter traffic based on the source address. However, your extended ACL can also filter traffic based on your destination, your protocol, and your port number, so it can filter a little bit deeper. This allows your network administrator a little bit more flexibility in the type of traffic that can be filtered and where to place the ACL. The basic rule of thumb for placing extended is to place it as close to the source as possible. Okay, remember, ACL is close to the destination, extended is close to the source. And you can only place ACLs on devices that you can control. Okay, so therefore, placement must be determined in the context of where the control of the network administrator extends. Okay, you can't put an ACL on a device that you don't have control over. Okay, I know that seems common sense, but it needs to be said. So you can only put ACLs on devices that you control.